So this is block 1 general physics. Yesterday we discussed topic 1.3, which was about the mass and the weight of an object, and today's topic is about the density, topic 1.4. So in this topic we will relate basically the mass and the volume to find the density. What are the learning objectives? You should be able to use the equation. This equation we will discuss. What this is the equation for the density. You should describe an experiment to find the density of the liquid and regular shaped solid, and you should describe the determination of a density of irregular shaped solids and predict whether the object will float on the basis of density data. Basically, first the definition of a density or concept of the density. Density refers to mass present in unit volume. So how much mass is there or how much matter is there in a unit volume, that we refers to density. Example, we have two objects, they have the same volume, but object A is having only 3 particles and object B is having 6 particles. So which object is having more matter in a unit space? Which object is having more matter, more particles in a unit space, A or B? So B is having greater amount of matter in a unit volume. So what we can simply say, we can say that B is having higher density and we can say A is having lower density. So the concept of the density is amount of the particle, number of the particle present in a unit volume, or amount of matter or mass. We can also relate matter with mass. So we can say mass present in a unit volume, we call that as a density. If we have more matter in a unit volume, we call that as having high density. If it is having smaller, if it is having a smaller particles, a small less number of the particles or less matter in a unit volume, we call that as it's having a low density. Is it clear? The concept of the density, like amount of matter or how much mass is there or how many particles are there present in a unit space. Then another example, for example, if we have two objects of different volume but they have the same number of the particles. This is having 3 particles, this is also having same identical 3 particles. Which object is having more matter in a unit volume, or which object is having high density, more matter in a unit space, in a small space more matter, A or B? Amount of matter in a space, in a unit space, is called known as the density. So which object appear to have more matter in a unit space or in a small space more matter? So when you check, like if I say take a unit space, like example, I took this as a unit space. So I can find in a unit space, I can find 2 particles. Here in a unit space, the same space, I can only find 1 particle. So it means it contains more matter or more particles in a unit space. So A is having the high density and B is having the low density in this example. So two objects, if they have the same mass, the object which is smaller, it means it will have high density, that it will have more matter in a unit space or in a specific space or specific volume, it will have more particles. Is it clear, this example? So the number of the particles or amount of particles present in a unit space, we simply call that as a density. In the previous example, two objects were having the same volume, so we just identify by matter. In this one, two objects have different volume. So what we did we take a unit volume. Unit volume means like we took a specific volume and we find number of the particle in a specific volume. So the first example, we have the same volume, okay, and these are the number of the particles. So if I want to calculate a density, density is how much matter is there in a unit space. So if I take a same space for both objects, for example, I took the same volume, I took this, the shaded gray shade is representing a volume I took. So I took the same volume for both objects. Which one you find more particles, A or B? Which object you're finding more particles in a unit volume? So that is A. So we can say that A is having high density and B is having low density. And I give another example. If we take two objects which are having different volumes, but they have same number of the particle in a different volume. Like this object is having say 4 particles, object A, or say 5 particles, and object B is also having same 5 particles. When I take the unit volume, like I took the specific equal volume for two objects, I took this volume, so this will be, the same volume will be like this. So when I took equal volume from the both objects A and B, which object is having more matter, A or B? So you can clearly see that A is having greater amount of matter. So A is having high density and B is having low density. So number of the particles present in a unit space or amount of matter or the mass present in a unit space, we call that as the density. We don't have to take a full shape. We normally take a unit volume. We take a equal volume for two objects and identify the number of the particle. So, and the density of the small part is same as the density of whole object. Even if we consider full shape, when you consider full shape, because this is having a large volume but few particles are there compared to when you check A is having more matter in a small space, like particles are closer and more matter. But for B, large volume and matter is distributed, so it will have less particle in a unit space, because the density means how many particles in a specific space or in a unit space. So when we are finding a density, the formula which we use to calculate a density, the larger volume will have a smaller density if the mass of two objects are same. So example, how we can find the density. The formula to calculate density, density is mass divided by volume. So when the mass of an object divided by the volume of the object, what you will get? You will get the density of the object. And it in symbolic representation, density is denoted by rho. It's a Greek alphabet. This is not P, it's called rho, RHO. Mass is denoted by M and volume is denoted by V. So density is mass divided by volume. So what is the concept of the density? How we define a density? The SI unit of the density is not P. This is a symbolic representation. This is a formula. The formula for density, when we write the density is equals to mass divided by volume. So the formula representation, density is denoted by rho, mass is denoted by small m, and volume is denoted by V. But what is the SI unit? How to get the SI unit? The SI unit of the mass is kilogram, kg, and SI unit of volume is meter cube. So SI unit of density is kilogram per meter cube. Other unit, because the mass can be in gram and volume can be in centimeter cube, so other unit can be gram per centimeter cube or gram per millimeter cube or kilogram per centimeter cube. These are units can be used, but the standard unit, the SI unit, is kilogram per meter cube. So what is the concept of the density? Basically, example, if you take same volume of different substances, they will have different masses. Like example, you took a wood which is having a volume of 1 cm3. Then you took water which is also having a volume of 1 cm3. And then you took iron that's also having a volume of 1 cm3. So we took equal volume of wood, water and iron. The mass of the wood is 0.50 gram. The mass of the water is 1 gram. And mass of the iron is 1 cm3 of iron is 8 gram. So which object is having the highest density? How to calculate a density? Density is mass present in a unit volume. So here the density will be mass 0.5 divided by volume 1, so we'll get 0.5 gram per centimeter cube. When we find the density of water, the mass is 1 divided by 1, so we'll get 1 gram per centimeter cube. And for iron, the density mass is 8 and the volume is 1, so we'll get 8 gram per centimeter cube. So if we take equal volume of these objects, iron will have the most number of the particles, followed by water, and at the last it will be wood. Is it clear? So which object is having the greatest mass, therefore it will be more dense. So in this example, iron is having the highest density. So the definition of a density is a mass which is present in a unit volume. Is it clear? Any question related to density? The equation for the density, what is the equation for density? The formula of density is mass divided by volume. The mass can be in gram or kilogram and volume can be in centimeter cube or meter cube. So density unit can be kilogram per meter cube or gram per centimeter cube. But which one is a standard or SI unit? SI unit is kilogram per meter cube, but other unit can be gram per centimeter cube. And this is the equation. So instead of writing the word density, you can use the Greek alphabet rho. Instead of writing mass, you can use small m, letter M. Instead of writing full volume, you can use capital V. And this is a triangle just to memorize the formula. So if I need density, it will be mass over volume. If I need mass, it will be density multiplied by volume. And if I need volume, it will be mass divided by density. If different size of objects have same density, it means object is made up of same material. What does it mean, this statement? Example, density can also be used to identify the type of the material. How we can use density to identify the type of material? Example, you have different size objects, and this is 2 gram and the volume is 2 centimeter cube. This is 10 gram and the volume is 10 centimeter cube. This is 3 gram and the volume is 3 centimeter cube. So when I find the density of these objects, object A, B and C, so density is mass present in a unit volume. The mass is 2 and the volume is also 2. So the density of object A is 1 gram per centimeter cube. The density of object B, the mass is 10, the volume is also 10. So it will be 1 gram per centimeter cube. And for C, the mass is 3 and the volume is 3. So I will get 1 gram per centimeter cube. So when I'm getting the same density for different size object, so what we can conclude, we can say that these objects are made up of same material. They have the same material, they are made up of same material. That is why they have the same density. So using a density, we can also identify a type of material. So if I say I have an object and it is made up of gold. So I want to show that this object is made up of gold. So how I can identify, like example, if you find any say a nail is there, iron nail is there, or a steel. So you want to identify the type of the material. So how you can identify the type of material? Simply you will find the density. So what we will do to identify whether this object is made up of gold. So what we will do, we will find its mass, and then we'll find its volume. Like example, the mass of this object, this is just an example, say mass of this object is 20 gram. Okay, and the volume of this object is 10 cm cube. So when I find the density of this object, density is mass divided by volume. So mass is 20 and the volume is 10. So I will get 2 gram per centimeter cube. Now how I can show that whether it is made up of gold or no? So I will compare the density of object original gold. And what is the density of original gold? The density of the gold is 19.3 gram per centimeter cube. That's the density of gold. So the object which I have, I claim it is gold. So I'm saying it is, but when I found the density, it is coming out 2 gram per centimeter cube. And the actual density of a gold is 19.3 gram per centimeter cube. So my question is this object made up of gold? Yes or no? I found the density of the object which I have, it's 2 gram, and original density of the gold is 19. So because it does not matches with the density of a gold, so you can clearly identify that actually it is not gold. It can be a mixture, it can be any other substance, any other metal or alloy, but it is not a gold. So this is the simple technique which normally jewelers are using to identify whether the object is made up of pure gold or silver. So what they identify, they calculate the mass by placing on the balance, and they know the volume. So mass by volume, it gives them the density. If it is a pure gold, then it should be 19.3. So using a density, we can recognize or identify the type of material. The mass of aluminium block is 27 gram and its volume is 10 cm cube. Calculate the density. What will be the answer? The density of this aluminium block? You can use the chat to state the answer. The mass is 27 gram and the volume is 10 cm cube. What will be the density of the gold? So when you use mass divided by volume, so mass is 27 and the volume is 10, so it will be 2.7 gram per centimeter cube. That's right. What is the mass of air in a room which is having a dimension 5 meter, 2 meter and 3 meter, and the density of air is 1.3? So there is a room. The volume of the room is same as the volume of air present in the room, and these are the dimensions of the room. Like one side is 5 meter, another side is 2 meter, and another one is 3 meters. These are the dimension, and the density of the air is given 1.3. So basically the volume of the room will be same as the volume of the air, because air is a gas, so gas take the volume of the container. So what will be the answer? If I need mass, mass is density multiplied by volume. So first I will get the volume. How to get the volume? Length into width into height. So 5 multiplied by 2, 10. 10 multiplied by 3, that will be equal to 30 meters. 30 meter cube. So volume is 30 meter cube and the density is 1.3. So 1.3 multiplied by 30, what I will get? I will get 39 kg or kilogram. Is it clear? Another example. Mass of a glass block is 125 gram. The density of a glass block is 2.5 gram per centimeter cube. Calculate the volume. So what will be the volume? Volume is mass divided by density. So what will be the answer? The volume of this object? So mass is 125 and divided by density, which is 2.5. So this will give us 50 centimeter cube. If density is gram per centimeter cube, final answer will be in centimeter cube. If density is kilogram per meter cube, final answer will be kilogram per meter cube. Now, simple experiment to find the density of a regular solid. What is the meaning of regular solid? The term regular solid means they have definite shape. Like you can have a cuboid, you can have a cylinder, or you can have a sphere. This we did in the first session, that how to get the volume. What is the formula for volume of the cuboid? The formula to calculate the volume of the cuboid. So if we want to find the volume, it will be length multiplied by width multiplied by height, because we are getting a length into width will give us the area. I'm talking about the volume. So it will be length into width into height. What about volume of the cylinder? How to get the volume of the cylinder? So that is pi r square h. And what about the volume of the sphere? That is 4 by 3 pi r cube. So these are the formulas which you have to, yeah, that's right, 4 by 3 pi r cube. That's the formula for the sphere. And what apparatus I need to get to measure the length, width and height? So here I need a meter rule. Here, because I have to measure a radius and height, so I need a micrometer and the meter rule to measure the height. And here normally, because it's a sphere, small object, so what we need to measure the, first we measure a diameter and then we calculate the radius, which is half of the diameter. So we'll need a micrometer. But how to get the density? Because the density is mass divided by volume. This is what we discuss is the volume. We'll get the volume of these objects. But how to get the mass? There are two ways to get the mass. One is directly by a balance, a beam balance. So using a beam balance, I can directly get the mass. Or there is also another way to get the mass. First, we will use a spring balance and we'll get the weight, and weight divided by gravity, so we'll get the mass. So both ways it is acceptable. First, using a spring balance, you'll get the weight, and weight divided by gravity, you will get the mass. Or you can directly say you will get the mass by using a beam balance. So how we plan this experiment for a regular solids? Example, we have a cube. So one of the side is 2 centimeter, another side is 3 centimeter, and another side is 4 centimeter, and the mass is 240. So what will be the density of this regular solid? So what we will do, we'll find the mass of a solid on a balance, we'll place on a balance and we'll get the mass. Then we'll measure the length, breadth and height and calculate the volume, which is length into breadth into height, or length into width into height, and then calculate the density, which is mass in a unit volume. So we'll get that as 10 gram per centimeter cube. Because it's a density, so it will be gram per centimeter cube. Is it clear how we work out the density of a regular solid, a solid with a definite shape? So they can change the question. They can say how calculate a density of a sphere. So for a sphere, what you will do, you'll find the mass by placing a sphere on a balance, then measure a diameter by using a micrometer, and then find the radius and use a formula. Diameter volume is equals to pi r square h, sorry, 4 by 3 pi r cube. You will get the volume of the sphere. These are some densities of objects. You don't have to memorize, but it is good if you remember these values, because commonly you will find a question related to this. So exam point of view, you don't have to memorize, but it's good that you learn these values, so it will make it easy to recognize or solve the question related to density. So density of aluminum is 2.7, iron is 7.86, brass, which is an alloy or a mixture, having a density of 8.5, wood is 0.5, slate is 2.8, glass is 2.5, lead is 11.3, marble is 2.7, and the wax is 0.89. And density of the water is also important. It is 1 gram per centimeter cube. how to work out the density of irregular solid. Irregular solid means solid which does not have regular shape. For example, if I say find the density of a stone, so we can find the mass of this stone by placing on the balance. But how to get the volume? For volume, we'll use a displacement method. So first, we'll find the mass of irregular solid by using an electronic balance. Then we'll add a known volume of a water into a measuring cylinder. Like example here, we add 50 cm cube of water. Then we drop stone, putting irregular solid into a measuring cylinder and measure the volume. That will be the final volume. Like example, the final volume is 80. So what is the volume of the stone? How much volume displaced? That is the volume of stone. So original volume was 50, final is 80. So when we subtract, we'll get the volume of the stone, which is 30. Mass is there, the volume is there, so we can calculate the density, which is mass over volume. And in this example, it will come out as 12 gram per centimeter cube. Is it clear how we work out the density of irregular solid? So we first calculated, we first measure the mass. These numbers are just examples to clear the idea. In exam, you don't have to write these numbers. In exam, if they say plan an experiment to find the density of irregular solid, so these are the steps which you should mention. You don't have to mention the numbers in exam, but I use the numbers to explain the idea. Is it clear? Anyone having a doubt or a question till now? Then how we can find the density of the liquid? Before working out the density of liquid, there's a simple question, example question. A lump of a metal has a mass of 210. So lump of metal is there which is having a mass of 210 gram. It is lowered into a measuring cylinder which contains water. The level of the water rises from 35 to 140. What is the density of the metal? Can you work out the density of the metal? Density is mass divided by volume. The mass is 210, but what about the volume of the metal lump? As the volume of the water level increases from 35 to 140. What's the final answer? Yeah, that's right. Good. It's 2 gram. So originally it is 35, then it is 140. So difference will give us the volume of the object, which is 105, mass divided by volume. So we got the density. Another similar example, a measuring cylinder contains 118 cm cube of water. When a small object is fully immersed in the water, the reading goes up to 132. The object has a mass of 42. What is the density of the object? A similar question. Yeah, what's the answer for the density of the object which is lowered in the measuring cylinder? Yeah, that's 3. This is not 0.29, it is actually 3. That's right, Ishra. Uh, not 0.29, actually it is 3. Sometime the object is too large. Yeah, the right answer was 3. Sometime the object is too large. So in that case, we can use a Eureka can. What is it's a for normally for large object. As you can see, if it is very small, we can use a measuring cylinder. But if it is too large, then which cannot fit in a measuring cylinder, so in that case we can use a Eureka can. It's a simple can which is having an opening, so and it's large enough to fit the object. First we fill this Eureka can till the level. We find the mass of a solid on the balance. Then we fill the Eureka can till this level, as you can see, the blue level. Then we add water until just is overflow, and then we add the object, place a measuring cylinder under the spout, and when you add the object, the water will transfer into a measuring cylinder and collect the water and read of the volume. Basically, the volume of water which we collect is same as the volume of object, because the object will displace the liquid and it will displace the same amount of liquid. So we'll read the volume of the liquid which is displaced. Volume of the liquid which we collect in the measuring cylinder is same as the volume of object added. This is normally used for very large object which does not fit into a measuring cylinder. Then mass divided by volume, we can get the density. Is it clear, this example? So the volume of the object is same as the volume of the water coming out from the Eureka can. Any question till now? Question or a doubt? So basically what happened, you take a Eureka can, you fill it with water. When you add this object into a Eureka can, the water will come out. So the volume of the object, the volume of this object is same as volume of the liquid which will come out. And so you will read a measuring cylinder like it's a 40 cm cube. So volume of the object is 40 cm cube, and the mass we already measured by a balance. So mass divided by volume, we will get the density of the object. So if you take a container, you fill the container with a liquid. So same amount of liquid will, the point where we should pour the liquid, that till this point. This is the level of the liquid, original level of the liquid. And when you add the object, the liquid will come out, and amount of the liquid which will come out is same as the volume of object. So I'll share another link and continue this discussion of density.